Okay, P.1, graphs and models. Chapter P is all going to be a review. A lot of it is even basic geometry, actually, probably Algebra 2, algebra concepts. They're not even pre-calc because our pre-calc book and our calc book go they go hand in hand. So you don't really review that much, but the other stuff is, we will have our test next Thursday is when I have it, but that seems weird to have a test Thursday. And we don't have school the following Monday, but it's next Thursday or Friday.
Okay.
So you know where we're at with that. Okay, we're going to talk about X and Y intercepts. And I'm going to try to leave these notes very brief, only what you guys need. So please bow in the topics. So how do I find an x-intercept?
Factoring.
Yeah, but like even more basic. Of any equation, any function I give you, how do you find an x-intercept?
So x equal to 0.
How about y?
Y equal to 0. That's what I said.
So it's always the opposite. So an x-intercept, your y, when it hits the x-axis, when a graph crosses the x-axis, the y is always going to be 0. Okay? So a y-intercept.
Set x equal to 0.
You set x equal to 0. Again, because you're always going to have an x being 0 there. So if I have y equals x cubed minus 4x, I need x and y intercept.
Adjust the second part.
It's okay. Operating on my pen. My notes on my notes are so much prettier than what I write for you guys. So how would I go about finding my x-intercept?
You would. Right.
0 equals x squared minus 4.
Yeah, you're going to factor out. That's why I wanted more general. Because Kale's saying that we're going to factor that out. And we're still not done factoring it out, are we?
No.
So we have x minus 2, and x plus 2.
Yeah.
This pen. This one's probably out too.
It's not.
So x equals what?
0 plus or minus 2. Plus and minus 2.
Okay, so 0 and plus or minus 2. It's not out, but it's really light. Oh, I bet you can't see green. So, but how do I write an x-intercept?
As a coordinate.
That is the coordinate. So I have 0, 0, negative 2, 0, and 2, 0. Okay, I would prefer that you always label when you're doing these your work. So you know, I know, it actually saves a lot of confusion. So for my y-intercept, I let x equal 0. So y would equal what? 0 minus 0, so it is 0. Now, remember the rule. If 0, 0 shows up in one intercept, it has to be what? Be in the other. Testing for symmetry. We talked a little about this last year, not a whole lot. We're going to use it quite a bit in certain parts of calculus. So we have tests for symmetry. So symmetric with respect to the y-axis. So we're checking for that. If you replace x with negative x, you get an equivalent equation. So what does equivalent equation mean?
It's the same.
You get the same. So when it's a symmetric about or with respects, I usually use about. The y-axis, you're replacing x with negative x and then simplifying, and you should get the same exact equation you started with. So symmetric with respect to the x-axis if you replace, anybody want to guess?
Y for negative y.
Yep, y with negative y, and you get an equivalent
Equation.
Okay, last, symmetric. Am I too low? No,
No,
that seems really small. You good?
it's good to be.
Okay. If you need the lights off, you can. With respect to the origin. If you replace both y with negative y and x with, evidently there's an e on the end of with now, negative x, and you get and equivalent equation. So you will be checking all of them, x, y, and the origin. So check your symmetry of 2x cubed minus x. And again, I just label it. I put x-axis. I always do x-axis first. I know their list started with y-axis, and that was the way it was in the book, so I kept it that way. But I personally always start with x-axis first. Okay, so x-axis, I replace what?
Replace y for negative y.
Okay, so I have negative y equals 2x cubed minus x. Then I have to solve for y. So y equals,
Negative 2x cubed plus x.
because I multiply both sides by a negative, right? So is it symmetric about the x-axis? Nope. Not, no, whatever you want to write. So y-axis. I get y equals 2 times negative x cubed minus negative x. Now remember the value of parentheses, right? So that would reduce to what, or simplify to? Negative 2x cubed
Plus X.
plus x. So is it symmetric about the y-axis? No. And then we have the origin. Now do not assume, because it doesn't have to have any symmetry, correct? So I always have people, oh, well, I checked 2 and it's not, so it has to be the other one. Nope, it doesn't. So then I replace both. So I would have negative y equals 2 times negative x cubed minus negative x. I always just simplify my x's first. And you just did it over here, didn't you? So you can just rewrite that negative 2x cubed plus x equals negative y. So I multiply both sides through by my negative, so I get y equals 2x cubed minus
That's
x.
Look at that.
So this is a
Jeez.
yes. I'm excited. And again, we talked about that last year, but we really didn't do it much. It's something that we'll do more and more through the graphing unit, and then it will kind of go away and then just pop up randomly. Easy way to remember it, if you're checking x-axis, you do the y. Y-axis, x, and then the origin is both. Kind of like the x-intercepts, right? If you're checking for x-intercept, you do 0y. Y-intercept, you do 0x. So the last thing I've got for notes for you guys, like I said, there's a little bit more stuff in there, but these are things I thought that we needed to go over. There's some parent function stuff in there. I'm gonna leave you to your own devices on that one. Okay, points of intersection. What is it? What is a point of intersection?
Where two functions cross.
Okay. Two functions where we can, we will have a lot of non-functions. So two equations cross, two curves cross. Where two objects meet. We have lots of intersections in our world now. So how do you find points of intersection?
By setting your equations equal to each other.
And that's it. Set equations equal to each other. So I have x squared minus y equals 3. X minus y equals 1. Now I just thought about something. You can set them equal to each other, but could I also solve one of them for y and substitute it into the other one, or one for x and substitute it in for the other one and kind of solve that? Yes, you can. To me, I pick the method that the equations kind of lead themselves to. I'm not going to solve for x in the first one at all. Why?
Because one's squared and one's not.
Right, and I'd have a square root happening, and I don't have a square over here to get rid of it, and I don't want to mess with that. So, do you guys want to set them equal to each other, or do you want to solve for one variable? What do you want to do?
We'll set them equal to each other by setting them both equal to y.
That work for you, Autumn? Okay. That's what I initially did, but then I looked at the other one. I'm like, I could have just easily done the other. So what do we got? X squared minus 3 equals y. And what? X minus 1 equals y. So that's that transitive property, right? So now x squared minus 3 equals x minus 1. Because if they both equal y, they have to equal each other. guys are going, so I'm just gonna go without talking. Okay, did you both get -1 and 2? Okay, but am I done?
No, you have to put her back in to get
Right,
a full.
because I want points of intersection, so I have to do points. I'm picking the second equation. How about you? I'm plugging it into that one. So we got what? -1 minus 1, so -2. And 2 minus 1, so 1. We good?
Yeah.
Okay, so your assignment is long. You notice if you look at the board, you have today and tomorrow. I would prefer you get as much done tonight as you can, but don't be staying up all hours. Okay, it doesn't have to be all done if it's late. You've got tons of other homework. I don't know other classes. Are you guys in chemistry this year, or did you take it last year?
It's a junior class.
You didn't take Are you taking physics this year?
Anatomy.
Anatomy.
/physics.
What about physics?
I think people take physics here.